So here's a challenge for you. What is the difference between these two photos? Well, except for the obvious that there are two completely different targets, one was taken in an area with basically no artificial light or light pollution in that area whatsoever, whilst the other was taken from my urban inner city balcony in central Stockholm, where I live, the most light polluted area in Sweden. Living in central Stockholm with all of this light pollution, I really need to be a bit more portable. So I have optimized my gear for portability, so I can easily take my telescopes and cameras, put them in a car and drive away from this really bright area. Let's say like 40 or 50 minutes away from here. So I can take images from a way more darker location than this. This, however, has now ended up in me having two image sets, one that is taken in a really bright location and one a little bit darker location. So I figured I'd do this video so we can compare these two types of astrophotography and see what the difference is and if it's really worth going to darker locations. But before that, let's talk a little bit about light pollution and what that actually means. So light pollution is basically unwanted light. Light that is artificial, that comes from us humans, and that pollutes the astrophotography targets, the light from the astrophotography targets, which are really dim, and the light pollution that surrounds us, well, just destroys the image that we're trying to take. Light pollution is actually very measurable. Scientists have defined a scale called the Bortle scale, which ranges from 1 to 9, where Bortle 1 is complete darkness. There is no artificial light in the vicinity whatsoever. It's like what we had before humans, or like what we have on Mars or other planets. And then Bortle 2, a little bit brighter, Bortle 3, 4, 5, 6, 7, 8, and finally Bortle 9. Oh, and if you're curious about the Bortle scale, there's actually a web page where you can browse, I think, the entire Earth. It's like Google Maps. Well, you can check it out. It's lightpollutionmaps.info, where you can see how bad the light pollution is in your area and the vicinity of your area. It's really cool, actually. I live in Bortle 9. So when I want to go to a darker location, I take my car and I drive to a Bortle 4 location, which is basically the darkest I can get by a reasonable amount of time needed to drive, like 50 minutes or something. And still then I have to know in which direction I'm going to shoot and which direction I'm going to take the car. So for instance, if I want to shoot towards the west, I don't drive towards the east to a darker location, because then I will have Stockholm or the inner city in my west, and that, just like the light sphere coming from that, will actually still be light polluted. So if I want to photograph towards east, for instance, I need to drive east as well. And if I want to photograph west, I need to drive west. And for north and south, of course, the same things. And there are a few Bortle 1 locations in Sweden, but they are super inaccessible. I mean, we're talking like the middle of the Baltic Sea, or like some mountain tops up in the northern parts of Sweden. So Bortle 1 isn't really that realistic for me. But Bortle 2, however, is more accessible and not that easy to go to. Takes a bit of like 6 to 8 hour drive, but still I have some Bortle 2 images and I'm going to show them to you soon enough. Bortle 4, however, is very accessible for me. 50 minutes drive from here, and I am in a beautiful Bortle 4 location, and I'll show these images as well. But enough talk about the Bortle scales. Let's get to some example images. So this image was taken by my mobile phone in a Bortle 2 location. This was taken during an Astro party that I went to last year, and you can clearly see that the sky isn't dark. there is something there. It's a bit diffuse, you can't really see what it is, but what we are actually looking at is the Milky Way. Millions and millions of stars that are like super dim and super far away just creates this, well, street of milk, the Milky Way. It's like somebody spilled milk all over the skies. And if I take the same area, or roughly the same area of the sky from my Bortle 9 location, it's going to look a little bit like this. You can see that it's very bright, that the surrounding areas are very bright. The Milky Way is completely gone, and you can only see a couple of stars, like the brightest stars in the sky. So this is what we are missing out on. This is what our children are missing out on. We have lost the connection to ourselves and our place in the universe. We are on a small planet on a very big universe, and like we have lost like the reminder of our place in this universe, and all we care about are like superficial stuff. But yeah, this video isn't about that. Let's continue on to the images. Oh, and if you like this video so far, do give it a like. It helps me out a lot. And if you have something to say, do write that down in the comment section. I try to answer all of your comments. And of course, if you want to see more of my content, don't forget to subscribe. And yeah, let's move it on. Okay, so let's go back to the images we looked at in the beginning. And there is actually a very fundamental difference in these two images. One is RGB image, like we would see with our own eyes, and one is actually blocking out 99% of the unwanted light, just looking at a very small patch of light that comes through our atmosphere. So out there in the universe, you have a few gases that are very dominant. For instance, hydrogen, sulfur, and oxygen. So oxygen is like this teal color. It's a mix of blue-green colors, and it glows in a very specific wavelength. It's very easy to target that wavelength, and by using what is called narrowband filters, you completely block out the unwanted light, letting only the light frequency, the very specific color from the oxygen 3 gas in, and you collect that data, and you can do that in a very light polluted area. The same goes for hydrogen and sulfur. The problem with these two gases is that they glow in red or very red, as in infrared. They are out of the human eye's capabilities to see, at least by maybe 90% or something. So the cameras need to be sensitive for infrared light, much like the James Webb telescope that we just sent out there. We. Well, yeah. And these are some examples of narrowband images. This is one example. This is a narrowband image, and this is another narrowband image. The main difference is that RGB imaging, or color imaging as our eyes would see it, doesn't work very well in the inner city. You have so much light pollution, completely destroys the target you're trying to photograph. So in this inner city Bortle 9 areas, I need to use narrowband filters. I need to completely block out the unwanted light, only looking at glowing gases, or nebulas that they are called, and they are basically only visible from our own galaxy. All of these nebulas that I photograph are within our own galaxy, so they're very close astronomically seen. So when I want to photograph galaxies, or when I want to photograph dust, I have to leave the inner city. I have to go to a Bortle 4 or a Bortle 2 location. All of these images are not possible to take from the inner city. But I have tried. So let's have a look at an example. I have taken the Iris Nebula. It's a reflection nebula with lots of gas and dust, and it's very hard to take this from a Bortle 9 location or the inner city location, but I have tried. This is the results. If we compare this image from a Bortle 4 location, I ended up with this image. Now you can clearly see that the difference is huge. It is basically impossible to photograph this kind of targets from Bortle 9. So there you have it. That's the difference between Bortle scales, and also that's what's happening to our skies when we light pollute our skies so much as we do. But for the sake of this video, I'm going to end there. I hope that you might have learned something and enjoyed this video. And if you do give it a like. It helps me out a lot to reach out to other people as well. And if you have any thoughts or suggestions for, like, say, another video, do give me a comment in the comment section. And if you want to see more of me, don't forget to subscribe. And I'll see you next time. Bye bye for now.